Hello everyone, this is Y. Manohar Reddy, Department of Cybersecurity, Institute of Aeronautical Engineering. Today I am going to discuss about the concept of primary indices and secondary indices. Primary indices and secondary indices, which is also called as what primary and secondary indexes in indexing and hashing methods in DBMS. So there are different types of levels of indexes out there. So one is like primary index, secondary index and multi-level index. So maintaining the indexes for accessing the data very fastly. So reducing the time to access the data, reducing the time for updating the data, reducing time for insertion of the data. So indexes are used to perform these all the operations: insertion, updation, retrievation. For these all operations, it takes a less amount of time. It takes only less amount of time that we can call it as an access time for retrieve the data, access time for update the data, access time for delete the data. So here we are going to discuss about the primary and secondary indexes. So what is meant by primary index and what is meant by secondary indices? So indices offers substantial benefits when searching for the records. So indexes are only used for searching for the records. Without maintaining the indexes, we are not able to access the records in particular time. So there may be a chance to accessing that records with a lot of amount of time. So to retrieve the data, to retrieve that records very fastly, we use it to maintain that indexes. So here updating indices imposes overhead on database modification. So to modify the data on database, it takes a lot of time, because why we are saying that to update any record, we have to perform first what read operation. We have to perform what read operation. Then next we have to perform what write operation. We have to perform what write operation. Again, then next what we need to do, we need to perform read operation, because the updated data is applied or not. Updated data is applied or not. So to see that, we have to perform this read operation, write operation, as well as read operation. So at this moment, it takes a lot of amount of time. It takes a lot of amount of time to update a record. So when a file is modified, every index on the file must be updated. So when a file is modified, automatically every index on the file must be updated. So every index on the file must be updated. So sequential scan is nothing but what? A sorting scan. So there are a sequential order of records are there. So we need to do what? Each and every record has to be scanned. So one record has to be scanned, then next second record has to be scanned, third record has to be scanned, fourth record has to be scanned. But for using by using this index mechanism, we can able to see the particular record which you want to update directly by maintaining that indexes. So here sequential scan using primary index is efficient. That's what we are telling here. But a sequential scan using a secondary index is an expensive. So sequential scan using primary index is efficient, but sequential scan using secondary index is somewhat expensive because of maintaining that index mechanisms, maintaining that index records is to be expensive. So primary index means we can have maintaining one type of buckets, but for the secondary index we need to maintain again one type of bucket. So it takes a lot of amount of cost. So that's why we can say that secondary indexes is more expensive than primary indexes for sequential scanning. Each record access may fetch a new block from disk. So each record access may fetch a new block from disk. Block fetch requires about 5 to 10 milliseconds. Block fetch requires about 5 to 10 milliseconds versus about 100 nanoseconds for memory access. So it takes a lot of amount of time. It takes like block fetch requires about 5 to 10 milliseconds, whereas memory access purpose it takes 100 nanoseconds. So Accessing time for the records is also very less by using these primary indices. And multi-level index. So primary index is maintaining only one level, but secondary index is maintaining what secondary level. But for multi-level index means you can create more number of indexes to access the records. So at this moment, multi-level indexes maintaining is very cost and efficient. See, if primary index does not fit in memory, access becomes expensive. So if primary index does not support it to memory, then there is no choice to access each record. So at that moment we have to go for multi-level index, which access becomes expensive. So for that solution, what we can expect that, so treat primary index kept on disk as a sequential file and construct a sparse index on it. So sparse index is nothing but what? Selecting a particular search key values. So based on that only we are going to fetch the records. Based on that some specified search key values only we are going to fetch the records. And here in this sparse index we can say that outer index as well as inner index. So what is meant by outer index and what is meant by inner index? So outer is nothing but what? A sparse index of a primary index. So which is outer index, which specified it as a primary index. But inner index is what? The primary index file, which contains the block of files, right? So which is nothing but inner index. So outer index is nothing but the primary index which already kept for the all index files. But inner index is nothing but what? All the primary index files which inside of the block. So if even outer index is too large to fit in a main memory, so if outer index is too large to fit in main memory, at another level of index can be created. So if it is not sufficient to fit inside of the main memory, then we will choose another level of memory which is accessible to fit in the main memory. So at that moment we have to create another level of memory which can be created. So indices at all levels must be updated on insertion, on or deletion from the file. So indices at all levels must be updated on insertion or deletion from the file. So on insertion as well as deletion from a file. So that levels has to be updated. So primary indices, primary level updated, you have to secondary level updated as well as multi-level also updated. So primary level you have to update, secondary level also you have to update, and multi-level also you have to update. So by updating these all the levels, it becomes more expensive. And more efficient. So this is why we can choose for multi-level index for because of the primary index does not fit inside of the main memory. Does not fit into the main memory. So here we can look at is multi-level indexes. So this is an outer index which shows that what? Primary index. And inner index which shows that what? Primary index files. So primary index files it shows, and each and every files are representing data from the data block. So these two are index files. These two are the index files, and this is block file. So this block files contains what? Data. Block files contains what? Data. But these index files contains what? Indexes. So indexes are nothing but search keys. So here outer index identifies that outer index contains what? Those two. Index block 0, index block 1. Like that it contains number of primary index It contains number of primary indexes. Again, each and every primary index contains what? Primary index files. Each and every primary index contains what? Each and every primary index contains primary index files. So that file contains what? That file contains what? Either ID, either name, either address, either contact, any of the data which contains as a such key in the primary key index file. So primary index file contains what? That search key values. So based on that search key value, you are going to retrieve the data from data block. So this data block contains what? Entire the data of records like name, contact, address for each and every primary index record. For each and every primary index record. So here it shows that what? Data block 0, and the secondary shows that what? Data block 1, and from here it shows that what? Data block 3, and it shows that what? Data block 4. So like that, different types of data blocks are there. Different types of data blocks are there. So all these will be treated as multi-level index for which is not fit into a main memory of primary index. So that's why we are partitioning that primary index and secondary index into multi-level index. So here, which is represented as both outer index and inner index. So outer index maintains what? Primary indexes. Outer index maintains that what? Primary indexes. And each and every inner index maintains what? Primary index files. Primary index files. So which files are contains search key values. So based on that search keys, the data block is going to be, the data which is inside of the data block is going to be fetched, is going to be retrieved. So this is all about multi-level index. Multi-level index. So which is clustered as a file index file records. So each and every file records will be maintained with the help of inner index as well as outer index. Inner index as well as outer index. So how we are going to be perform a deletion operation on index. So before deletion of any index value, we need to perform that operation as a update. We need to take it as a operation of update. So what will happen? See here. If deleted record was the only record in the file with its particular search key value, the search key is deleted from the index also. The search key is also deleted. So what we are saying here, if deleted record, suppose here a lot of values are there, 10101 as an instructor ID, and this is the instructor name, and this is the instructor subject, course, and instructor salary. Suppose if I want to delete a records like called 10101 and 32343 and 76766. If I want to delete these 3 records with the help of the search key value as instructor IDs. So based on this instructor IDs only, we can delete that records. So at that moment, it says that what based on that search key value you are going to delete the record means it automatically deletes the search key value also. It automatically deletes the search key also. Search key also deleted. Because of we are deleting all the record from this index based on your search key value. So here we can use a different levels like a single level index entry deletion. So dense indices. So deletion of search key is similar to file record deletion. So similar to file record deletion. So deletion of search key. So wherever the search key is there, you are deleting that search key is similar to the file record deletion. So it says that what entirely file record deletion. And sparse indices. So dense indices deletion of search key is similar to file record deletion. But sparse indices. So if an entry for the search key exists in the index, it is deleted by replacing the entry in the index with the next search key value in the file. With the next search key value in the file. In search key order. In search key order. So if the next search key value already has an index entry, the entry is deleted instead of being replaced. Instead of being replaced. Because what we are going to say here, if any search key value is having the number of values, then it is deleted by replacing the entry of the index. It is deleted by the replacing of the entry of the index. So with the next search key value in the file, so that means search key order. So each and every search key order. So this is one, the next one, this one, next one, this one, this one. So like the way each and every record is pointing to the next record. Each and every record is pointing to the next record. So that is what sparse indices deletion, entry deletion. And dense index deletion of search key is similar to the file record deletion. But in the sparse indices deletion, an entry is replacing with the deleting by replacing of the entry in the index. So with the next search key value, it is going to be deleted. So if the next search key value already has an index entry, then the entry is deleted instead of being replaced. So before replacing that index value, the previous value which is already pointed to the current level is going to be deleted. Index update on insertion. So insertion also, if you are going to perform an insertion on the particular indexes, you can do first update operation. Update operation. That is nothing but write operation. So we are going to insert a values into the indexes. So there also we can have a single level index insertion. So that indicates that what? So perform a lookup using the search key value. Appearing the record to be inserted. So which based on the search key values only, it is going to be inserted. So suppose if we have the ID like 10101, so if I want to insert a value into this ID, if it is already existed, then it shows that what it's already inserted. So again, if you want to insert with the same ID, it is asking you to remove the duplications, like remove the primary keys also. But all these primary keys are treated as in primary indexes. So there is no possible to insertion of multi-level. So only single level insertion. So here, dense indices, if the search key value does not appear in the index, does not appear in the index, you need to insert it. But if already the search key value is existed, then you have to update the value. Of that index, but not you are going to insert a new value. And sparse indices here, so that is nothing but dense indices. And the sparse indices, if index stores an entry for each block of the file, no change needs to be made to the index unless a new block is created. So that is what we are telling. If already a value is inserted with the same ID, it is not allowed to enter new values, but it is allowed to update your values. So that is what we are mentioning here. And the sparse indices also. Or else you can create new block. And in that new block you can create the same ID. So if a new block is created, the first search key value appearing in the new block is inserted into the index. So if ID equals to 10101 is not in the previous indexes, then you have to create a block for it, and insert the index values. Then it is taken as its sparse indices. So it is created, it is inserted. But already inserted value is not going to be inserted once again. So if it is not there, create a block one and insert that values. If it is there, there is no need to insert one more values with the same IDs. So at that moment you can have the chance to update your values, but not to insert new values into this and multi-level insertion and deletion. So algorithms are simple extension of the single level algorithms. So we need to perform what multi-level of insertions and multi-level of deletions. So based on the index values we are taking, on that basis of index values, we are going to perform insertion as well as deletion operations. On that two basis, you are going to perform index values as well as perform insertion operation as well as deletion operation. So secondary indices. So frequently one wants to find all the records whose value in a certain field, so which is not the search key of the primary index, which is not a search key of the primary index. To satisfy the same condition, take an example. Example 1. In the instructor relation, stored sequentially by ID, we may want to find all instructors in a particular department. We may want to find out what all instructors in a particular department of the file. And in the example 2 also as above, but where we want to find all instructors with a specified salary or with salary in a specified range of values, salary values as well as or else a specified range of values. We have to verify that one. So for this, what we have to use secondary indices. So suppose take an example. So this is the primary index value which is contains IDs like 101010 and 202020 and 303030. This is the index values which contains the data block here. Data contains so values, employee names, employee values, instructor salaries. So like us. So instructor salaries. If we want to display with the range of values, you need to create again secondary indexes. So this is called as secondary indexes. So this is called as secondary and this is called as primary. So we are going to perform what? We are going to perform an operation which is delete or whether it is retrieve or whether it is insertion based on the conditions of the range of the value. So at that moment we are going to take a secondary index values. So we can have a secondary index with an index record for each search key values. So for each search key values you are going to maintain an index record. So this is an index record. So each and every index record maintaining this search key values. You can take search key values as instructor IDs you can take, or else instructor name you can take, or instructor subject you can take, or else instructor salary you can take. So if based on the questions we are taking that what instructor salary range. So from this question we may want to find out all instructors in a particular department. So we need to take the department as search key values. On that search key value department, so how many of the instructors are working with that department, we need to mention that. So taking as instructors IDs as a primary one, and taking as instructor course names as secondary one, instructor names as secondary one, and then data block. So this is the way we can understand to create secondary indexes for accessing the data. So once again we revise the topics which we discussed in the session. So what we are discussing in this session, so creating primary index as well as secondary indexes. So what is meant by primary index and what is meant by secondary index? So creating an index or index file records to searching all the records is called as a primary indexes as well as secondary indexes. So here the primary indexes, sequential scans we are going to use. Sequential scans we are going to use, and based on that sequential scan only we are going to fetch the records. So updating indexes imposes overhead on database modifications, we already said. So when a file is modified, every index on the file must be updated. So to insert value, to update the value, to delete the value, we have to perform what? Read operation as well as write operation. Read operation as well as write operation. For every insertion, for every updation, for every deletion, we have to perform what? Read or write operations. First read operation, then next write operation. So why we are creating this all the primary indexes and secondary indexes means to accessing the records at very fast time, very fast movement we are going to retrieve the records. So the multi-level indexes are offered to creating more number of indexes to access the records if primary index is not fit into the memory. If primary index is not fit into the main memory, so at that moment the access becomes expensive. So at that moment what we need to do, we need to create a multi-level index. So creating more number of indexes. So creating more number of indexes are nothing but creating what? Creating outer index, creating inner index, and creating a data block file. So creating all these values, we are going to use a multi-level of indexes. But the main purpose of creating multi-level index is if any case primary index does not fit into the main memory. If any case the primary index does not fit into the main memory, so it goes to access becomes more expensive. So at that moment we are going to choose the multi-level of index. So here we can see the multi-level of index indicates that what? This is an outer index and this is an inner index and this is a data blocks. So data blocks maintains what? Data blocks maintains data of each and every record. So each and every record, like what? Instructor. So we are talking about instructor relation, right? So instructor IDs, instructor names, instructor scores, as well as instructor salaries. So this is the data which is having inside of the data blocks. But to accessing all the records, what we are going to create? An outer index we are creating and inner index we are creating. So creating the levels of index. So this is called as multi-level index. So in the outer index, what we are maintaining? We are maintaining a search key values. Search key values are nothing but what? Index values. So you can take it as an outer index as inserting primary indexes, and the second one, inner index, maintains what? Primary index files. So primary index files which is maintained in the inner index, and each and every primary index file fetches the record from the data block, or fetches the records from the data block. So each and every outer index contains what? Primary index values, and the primary index value is pointing to the primary index file values, and the primary index file values are pointing to the data block values. So like the way the indexing mechanism appears to access the records with the help of indexes. That is nothing but with the help of search keys. How the indexing mechanism works to retrieve the data in the database. So this is all what happens in the multi-level of indexes: creating outer index, creating inner index, and accessing the data from these data blocks. So this is all about multi-level index. So how we are performing index update on deletion, index update on insertion. So to delete any of the values, we have to use index values. So index values are nothing but search key values. So on what basis you are going to delete your data? On what basis you are going to delete your data? So I am deleting the data based on the search key, instructor ID, based on the search key instructor ID. So that movement takes what? Index ID, instructor ID also deleted. Instructor ID also deleted. So instructor ID is deleting means that indirectly says that what? Entire instructor ID with the help of all records will be deleted. So there single level of index entry delete will be occurs, and as well as multi level of index delete will be occurs. So index update on deletion. So to delete all the values, you can use that search key as a primary index and perform the delete operation. And similarly index update to delete insertion operation, same. So here also index insertion also same takes place. So based on the search key values you are performing insertion operation, but to insert the values you can use a single level of index insertion in that dense indices as well as sparse indices. So dense indices insertion the values based on the search keys, but the search key value is already inserted. It does not take place to insert new value. But search key value is not inserted means you can create a new block to insert it. But if already inserted means just you are going to update your values in the data block. So that is what these dense indices and the sparse indices will be appeared to perform that index update on insertion. And the last, secondary indexes. So secondary indexes, why we are going to creating secondary indexes? So creating more number of indexes are only for the use of accessing the data is very fast. So there may be questions will be asking like instructor relations stored sequentially by means of ID, but we want to find out all instructors in the particular department. So how may choose to creating indexes, and how may choose to creating all the indexes and using these values to retrieve the data. So that is what we have to understand from these indexes, primary indexes as well as secondary indexes as well as multi-level of indexes. So this is all about primary indices and secondary indices. Thank you all.
Like, share and subscribe. Hit the bell icon for more updates.